All right, hi guys. We're going to go ahead and finish up our notes for the first section on alloys, our general overview of alloys. Last time we were together, we went ahead and we discussed what an alloy is and how the different types of alloys. We talked about the purpose. So, quick review first. Why do we create alloys? What's the purpose of those? Well, alloys are mixtures of metals, right? Including metals. So the purpose of an alloy is to enhance or change the property of that parent metal of an alloy, that base of your mixture. Examples that we have talked about include steel and how we add carbon to that steel to make it stronger, to make it more durable. Other examples, you just saw a video yesterday on the creation of bronze using by adding tin to copper, and by adding that tin to the copper, it actually makes the copper stronger and more durable, so it can to make the bell that they are creating. And by adding that tin, we have the copper can withstand the hammer from the bell, and it can also resonate that sound a little bit longer, make it last longer. So again, we're changing those properties. So today we're going to go ahead and move forward. We're going to talk about, okay, how our alloys made. And so yesterday we saw on that video of them making that bronze alloy. So an example of this would be bronze. But basically what they did was they melted there you go, their ingots of bronze, ingot of tin from Southeast Asia and their copper from South Africa to create that bronze solution. So another element that we use that is done with this, brass, steel. This is our most common way of making alloys. Another example would be by turning them first into powders before they're melted and mix them together then. The purpose of doing this would be to have a little bit more control over the components and that percentage, so that mixture is a little bit more controlled. So brass, bronze, steel, brass and bronze, it can be done this way as well by powders. But other examples, aluminum alloys, chromium alloys, cobalt alloys. When we have industries, will use the powders to make these alloys as well. Okay. Another example that we have discussed about a different way of making alloys is to create a layer by firing beams at them. So you actually remember this because we watched a video on this on creating semiconductors and computer chips, because basically when you think about it, when you talk about what we saw yesterday in the video, what we've talked about so far with the substitutional alloys and the interstitial alloys, that these are basically crystal defects, right? Well, remember that semiconductors, computer chips, those are very, very controlled alloys by firing your two different conducting metals or conducting elements at your base silicon chip to help create those electron differences and create the signals for electrons. Okay, so we talked about that before. So this is a third way of making an alloy. That's, again, it's usually more of the tech field that uses that. Another way of creating an alloy is actually, you don't think of it as an alloy, but that's exactly what it is. It's plating. So plating is when you use electricity to transfer a layer of metal onto an object. So basically what's happened is electrodes are connected to two different pieces of metal. So you have an anode and a cathode, and with a battery connected to it, and when the energy is moving, the metals from that metal that are in your solution, what we call an electrolyte solution, which is where those those ions from those metals are deposited, are transferred onto a layer of the other metal. So in this case, you'd be looking at zinc being plated onto your copper here. Okay, examples that we use plating for include chrome, okay, when we plate bumpers and that sort of thing. Silver, we've talked about silver plated items, and gold, another thing that we use plating for a lot. Why do we do this? Well, basically because to have that layer on there, it's actually usually cheaper, less expensive way of providing decoration. For example, we have jewelry, coins, your wheels. You know, you want those flashy wheels if you, but you can't afford solid, right? And then, of course, utensils like silver-plated forks or gold-plated plates, that sort of thing. Another reason that we would use plating is to provide a protective layer that will stop corrosion. Okay, so for example, chrome, like with your wheels, it's actually not just because it's pretty, it's because it's going to stop that rust from happening. Another example would be galvanized steel. Putting that zinc oxide layer on the outside will help with that. So plating itself is not actually creating an alloy, but it's what we can do with it whenever we go from there. So one example that I hope to do in class is to plate a penny and use that to actually create a brass penny. So as you can see from this picture, in 1982, the U.S. government determined that it was actually more expensive to make a penny than the actual penny cost. So what they did was they took a small piece of zinc, and you can see how it has silver in there, and they took that zinc and they plated it in copper. So that's an example, but what we can do with it is actually create our own alloy. So what we do in lab is we take a penny, brand new penny, shine it up, get it all clean, and then we put it into an electrolyte solution, and we attach our battery to it, and we create a silver penny. But that's not the end of the story. So first of all, I'm going to show you what happens here. So there's our dish with our zinc plate in there. So that's a piece of zinc. And then in here, we're going to create a hydrogen oxide, zinc oxide solution. So you have some pieces of zinc in here to create your electrolyte. So again, these zinc are going to become oxidized and ionic. And as soon as we attach that electrode to it, you'll have some movement of electricity. So here you see the battery being put into or attached to your zinc plate, and then a penny on a spoon put into the solution. Now this is your your copper. The penny itself is a copper plate that is being put in an electrolyte. So let me go back here for 2 seconds. There we go. So this would be that zinc that we have in there, and this would be your cathode, your copper penny. So that's what we're looking at. Go back really quickly. And then this is a piece of copper wire that is being used to help transfer all of it on there. So basically it's creating a better connection between the electrolyte and that copper piece right there, which we know is a penny, right? As you can see in this picture, that the penny has now actually become silver in color. So what we've done is we've cleaned off all that dirty surface of the penny. Okay, this is what it should look like once it's all cleaned. You have a layer of copper, that layer of zinc inside, and then another layer of copper. By putting it into that zinc electrolyte solution, what we're doing is putting that plate across the top. Okay, so you now have another layer of zinc on your copper. What happens next is we take that silver looking penny and we put it onto a hot plate. And when the hot plate, when it's on the hot plate, it causes the atoms to move a lot more quickly, and what will start to happen, you'll have diffusion. Okay, remember we talked about how an alloy is like a solid solution? So those atoms are going to start to move from the outside, that plating, into the copper, and they'll actually, if you wait long enough, though, that copper from inside will also, the zinc from inside will also start to diffuse to the copper, and you have a nice even layer on the top that creates a brass penny. So here's your penny that you'd start off with. This is the zinc plated penny, and once you heat it up and you get those zinc particles moving in between the copper, you have a brass penny. So hopefully, once we get back to school, we'll be able to go ahead and do that lab. So if you have any questions, let me know. We'll go ahead and end here for today. Have a great one.